If you're at home, I edited the calendar. It's going to be a one-day lesson. You're not doing an alpha beta lesson. That's reflected in the updated calendar in Canvas. Okay? So 475. Example 2 is the textbook's attempt to connect calculus to physics. Well, most people have completed physics or they're in physics now, but not everybody. So this is the publisher reaching out and saying, this is an application of calculus and physics. And the other example we're going to do is an application of calculus and statistics. And very few people in front of me have completed statistics. Right? So you got this example 2. So take a moment, it's up there, just read the example. There's a picture in the margin, helps you see this. But what are you doing? You're saying the bucket of load would be the force times displacement. And their product would be 440 joules, which you can look at as saying that was the area under that curve. Okay, when do you do this in physics? September? Yeah, it's work, okay? So, you know, it's something you already covered. You haven't had physics. You don't need to be intimidated by this. I'm not going to assess you on it. It's not going to be on the AP calculus exam. How about the water alone? Well, this is the calculus part, so think about what they're saying here. You're going to anti-differentiate this from 0 to 20, which is the height that you're carrying this thing, but you're going to multiply the weight of the water by this factor. 20 take away y divided by 20. Where does that come from? Well, when the height is 0, where you're starting, you multiply the 70 by 1. Be 70. When the height is 20 at the top, you'd have 0 in the numerator because the bucket is leaking. And there wouldn't be any water left in it when you got to the top. So multiplying by this factor out here accounts for the bucket leaking. And if you did this, dy, which we're not going to, you can do it on your home screen, you would get that much work. And the rope alone. Well, the rope has this weight, this force on it. And then 20 take away y, because at time 0, you have to lift the rope 20 meters. By the time you get to 20, you don't have to lift it at all. And then you add them to get the sum of how much work is involved in the whole thing. Okay? So that's your model. Example 2, we're going to pause this and you're going to problem 5. All right, so problem 5. What do we got? From 0 to 20, 490 times what would the growth factor, which would make that 0 when you got to the top, which you can rewrite as this, which gives you 4,900. Then if you did the problem by hand, you would still get 4,900. Yes? Do not be like intimidated by the physics. You're not going to have to do it. It's just an application. But now we get to the interesting part. We get to the application of statistics. So the parent graph for the standard normal curve is y equals e to the negative x squared. So if you go to your calculator and you just go to y1, and you type second ln to the negative x squared and push. Push zoom 4 for now. That's not a very good window. Okay? So we're going to go to this window, which the stat children already have. We're going to go to -3 to 3, where the x scales 1, and the y's we're going to go from -2/10 to 5/10. What we want to do is go to Zoom, Memory 2, Storing, because your calculator will store one window. I don't know why it won't store more than one. It'll store one. So that'll stay there until you type over it. Well, that's not a very good window for this picture. It's not, because that's the pre-image. So what happens? We do a scale change to that. And our scale change is we expand our x's by a factor of √2 and our y's by a factor of 1 divided by the square root of 2 pi. What? Well, what that does is it makes the area of the curve 1, and it makes the inflection points occur at one step left and right. So you could literally just do that. How do you do it? You do the opposite. So you divide x by √2. You divide y by 1 over, or you multiply y by square root of 2 pi, and then you divide it both sides to make it calculator friendly. But you don't have to do that because it's set in your calculator. So you go to y equals, and you get down to y2, and you type this. Second distribution, 1. Where the x value is x, the center is 0, and the step is 1. I'm just going to paste that in y2. Push graph, and the red graph is the image. So if you notice this, in the red graph, when you go 1 to the left or 1 to the right, you understand? When you go above that, that's when the graph to the left, the graph stops opening up and begins to open down. It's an inflection point. To the right, it stops opening down and begins to open up. And the area under the red curve is 1. Well, that allows us to use the standard normal curve in statistics. So we're here. Problem 7. So I drew the curve, okay, and then I put 0 in the center, and underneath one step, the 1 on the x-axis, I put a 1, I put a -1. And whatever the magnitude was for that inflection point, you just copy and paste that to the right. So whatever this magnitude is, it stays that magnitude. 2 steps to the right, 3 steps to the right, 1 step to the left, 2 steps to the left, 3 steps to the left. Okay? This is this answer to the mystery. Why do you get 200 points for writing your name on the SAT? Yeah, they're standardized scores. What does that mean? You came from here. The SAT came from a test the Army developed. So the president of Harvard had a problem 100 years ago. And the problem was that Harvard was the #1 party school in the country. For one reason. Almost. The only way to get into Harvard is when your father went there, because women weren't allowed in. You had to be a legacy. So these kids knew from before your age, they were going to Harvard. I'm not doing any work, I'm going to Harvard. They were entitled. Women weren't admitted. People whose fathers didn't go to Harvard weren't admitted. And the president looked around and said, this is a disaster. We have to have some way to create a meritocracy. The people earn their way into Harvard. So he asked around, the Army had this test, which morphed into the SAT test. They said, okay, let's come up with this. Does it make sense? Like, let's test two things that are important. How about language, arts, and math? Yeah. How about other things? Well, yeah, but let's emphasize what's really important to predict you succeed. Language, arts, and math. Let's think of a round number. Okay, 1,000. 1,000 is going to be the center score. So we're going to give half the language arts and half the math. So for the math scores, this is 500. The average math score. And they said, okay, we're going to count out 3 steps to the right, but to make this easier to do it, we're going to make the steps a round number. We're going to make them 100. 600, 700, 800. 3 steps to the left. 200. Why? Because 3 steps right and left of the curve captures 99.7% of the data points. That means there's only 3 out of 1,000 people missing. There's no point in chasing after the 3 out of 1,000. Which means, ready? 1.5 of them are over here, but higher than an 800. Really? If you got an 800, I think your ego is satisfied. You don't need to get higher than 800. Except 1.5 of them are over here. We give you 200. I think we made our point. We don't need to give you worse than the 200 you paid to take the test. So you get 200. So this graph is symmetric about the center of 500. That makes sense? Because 3 steps would capture so much of the curve, 99.7% of the area of the curve. See, the area of the curve is 1. But it has an asymptote on the x-axis to the left and right. We can quantify that that area is 1 when we get to chapter 8. We're not there yet. So if we go back to the example, it's about spinach boxes, okay? And it tells you the mean is 10.3 and the step is 0.2 of an ounce. So I just marked it here. Here's 10.3. Every step is worth 0.2. 10.5, 10.7, 10.1, 9.9. So the question asks, what percentage of the spinach boxes weigh between 10 and 11 ounces? For 10 and 11 ounces, Ready? Here's 10 ounces. Negative 1.5 steps. Yes? 11 ounces. 3.5 steps. So I just did math 9 to the standard normal curve, which is, I have it Y0, you have it already in Y2. Yes? You math 9 that from negative 1.5 to 3.5. And it's telling you 93.3%. Then underneath it is the way we do it in statistics. Well, it's the same thing. Instead of doing math 9 to this, we just type the normal CDF. You have PDF, probability distribution function, in your Y2. We're doing CTF, which is cumulative. But here's the calculus. And then B asks, what we'd expect to weigh less than 10 ounces. Less than 10 ounces. Here's 10 ounces. So I just pick some arbitrary number, negative 5, all the way over here. Pick negative 100, doesn't matter. I went from there to the left to negative 1.5, which is 10, and you get about 6.5%. Then C asks, how many are exactly 10? The line has no dimension. There's no answer to that. Right at 10, that line has no dimension. There are no that are exactly 10. We can't predict that, okay? So put this up here. That's your model for you to go to problem 31.